But what we're really looking to do with Neo is give our customers more control, allowing them to not only go faster, but produce a much higher quality part.
Guys, I'm really excited to be here today with my buddy Al for the big unveiling of this Neo machine, because we're going to talk about flexibility combined with power and what these attributes are going to bring you, the potential customer and existing customers with Mazak. And Al is so well spoken. I love spending time with him. Al, thank you again for being a part of MTD.
Super happy to be here.
Let's talk about this Neo. I know you and I can talk about this type of technology all day and night, but let's try to really get this empowered moment for the audience. What are we doing here with this Neo machine?
Well, as we see the increased power levels every year getting higher and higher, we know that, of course, high power gives high productivity. But what we're really looking to do with Neo is give our customers more control, allowing them to not only go faster, but produce a much higher quality part.
Well, when we go faster, we can make parts quicker. And I know that with some of your other machines, we're looking at 32 millimeter. What are we jumping up to on thickness with even the harder materials on this Neo machine?
Yeah, so when we get into those high tensile strengths, such as stainless steel, even Inconels or titaniums, we can always go up to 25 millimeter. But in this case, we can double that thickness, go up to 50 millimeter thickness on stainless steel.
So now we're talking about 50 millimeter of thickness, but we're not sacrificing the flexibility. What are some of the options on this machine where we say, oh, you the customer, you can do whatever you want here?
Right, so traditional fiber lasers, we've been able to deliver a high power laser beam, but essentially with one heat profile. With the Neo platform, we have proprietary technology that allows us to control not only beam diameter and wattage of power, but also concentrate where that power goes in the total array of the laser beam. So we're actually balancing power distribution in the beam itself.
That's incredible to talk about, but even something possibly even more fascinating from my perspective is some of the proprietary items you have here and this software that's behind me, what you've integrated, but the way this AI can read so quickly. Can you talk a little bit about that?
Right, so these machines are moving so fast that when we see or identify that the cutting process may be going different than what we had planned, we have an intellectual property inside the cutting heads proprietary to Mazak that actually allows us to make adjustments on the fly where the control itself is watching and adapting the cutting process on the fly without the operator having any intervention.
It's absolutely incredible to think about, because we know there's some imperfections in some of the materials, right? And I believe that we've discussed this and said, okay, well, previously the machine would just stop, right? And now we can read it all, right?
Correct. Of course, particularly today, we see a wider range of steel, right? So we're not looking at just one grade of steel. We may have grade 80, grade 50, A36. So when we say steel, could be a wide range of different types of composites. So the cutting condition for a particular type of steel could be quite different from one grade to another, and throughout the mill of a coil could also change. So rather than having the operator kind of monitor the cutting process, we have a much more powerful CNC control that is watching the cutting process for the operator and adapting feed, speed, gas pressure, focal setting, all on the fly.
We talk about automation a lot, and we talk about autonomous running a lot, and you just mentioned an operator would be the previous way to look at all this. Are we now running autonomously?
Yes, it is exactly the term we use, the term of autonomous monitoring. So don't forget, we can provide quite a range of automation solutions to combine with the laser cutting process. So automatic material handling systems. Well, if these machines are running through the night, unattended, we don't want to cut a whole bunch of scrap parts. We want to be able to produce not only the parts we need, but with high quality and consistency. So having a control that has these AI features and adapts itself to the cutting process ensures that when we run 3, 4, 5 hours of particular type of material, they're all good parts.
The massive amount of reduction that goes into scrap, I can only imagine what's going to be created from this. The flexibility that you've mentioned and the ability to cut hard materials at deeper or thicker depths. How excited are you to unveil this machine to the world here in the U.S.?
We're super excited because everybody wants a higher power machine and get that greater productivity, but we really want to give the customer just more than just high power. We want to give them a super high quality part and put that control in their hands through a much more powerful operating system and a much higher performance machine combined.
Al, this is absolutely fascinating technology to me. I really appreciate you bringing us into Chicago, into your new facility, the expanded facility, and everything you're doing with service and support and sales. Keep up the amazing work, and on behalf of MTD, we wish you continued success, my friend.
Thank you, my friend.